Let's solve the following problem. Find the amount of money made if you invested $25,000 at 4.3% interest for 8 years, compounded monthly. To find the amount, we will use the following compound interest formula. A is the amount of money accumulated at the end of T years. P is the present value or the beginning amount of money, sometimes called principal. In our case, P is $25,000. The problem says if you invested $25,000. R is rate of interest as a decimal number. Here R is 4.3%, and after we convert the percents to decimal number, we get 0.043. N is the number of compounding periods in a year. N is 1 if compounded annually. N is 2 if compounded semi-annually. N is 4 if compounded quarterly, 12 monthly, and 365 daily. In our example, the money is invested for 8 years compounded monthly, so N will be 12. T is the time period in years. In our example, T is 8 years. We substitute P, R, N, and T with their values. P, the present value, is $25,000 times 1 plus R, it is 0.043 as a decimal number, over N is 12. We close the parentheses. Raised to the power of N, 12 times T, 8. So we need to evaluate this expression. We are going to use a scientific calculator for that reason, but let's see how you would do the work if you do it by hand. You must evaluate the expression in the parentheses first. So in the parentheses we have a division and addition. We should start from the division. I'll use a scientific calculator. It is a free one and it could be found on the website www.math.com. There you have to click on calculators and select the scientific calculator. It is the one that you see right now. So I will type 0.043 divided by 12. Equals. Then we need to add 1 to this result. Plus 1 equals. This is the value of the expression in the parentheses. This is the base of the exponent, and the power is 12 times 8, or 96. So this product 12 times 8 is 96. This key, y to the power of x, raises any real number to the power of x. That could be also real power. So I have the base of the exponent. You must enter the base first, then I click on this key, and now I have to type the exponent, 96. And I click on equal sign to get the result. This is the value of the expression of the exponent. Now I have to multiply this result by 25,000. So times 25,000 equals. And because this is amount of money, we have to round the result to the nearest hundred or cents. So it will be $35,242.79. A is the accumulated amount, or sometimes it is called the future value. The problem says to find the amount of money made, so we have to find how much money interest is earned over the 8 years period. The interest earned for this period will be $35,242.79, the future value, minus the present value, $25,000, the beginning amount of money. And the result is this, $10,242.49. The more often interest is compounded within a given time period, the more interest will be earned. However, there is a limit on the amount of interest, no matter how often it is compounded. When the number of compounding periods n gets larger, the formula for compound interest approaches a limit called the compound amount from continuous compounding. Here's the formula for continuous compounding. A and P and R and T have the same meaning as in the previous formula. E is the natural number and its value is approximately 2.7183. If $P are deposited at a rate of interest R compounded continuously for T years, then the accumulated amount in dollars on deposit is this one, A. Let's see the following example. Suppose $5,000 is deposited in an account paying 3% interest compounded continuously for 5 years. Find the total amount of deposit at the end of the 5th year. We're looking for A, the accumulated amount. We know the present value, it is $5,000. Times E, the natural number E to the power of R. The interest rate R is 3%, so we have to convert it to a decimal number. 3% as 0.03. And T is 5 years, so we raise E to the power of RT, or 0.03 times 5. Now it's time to evaluate this expression to get the accumulated amount. I'll open the calculator. Before to start evaluating the formula, let's see how to use the key e to the power. First, it is above the ln key, so I have to click first on inverse, and let's just try to directly click on this key, and it gives me the result of 1. It means that it requires to type the exponent first. I'll try with a simple example which answer I know. I know that e to the power of 0 will be 1. So let's clear it and start from the beginning. My power will be 0. Now I have to click on inverse and e to the power. It's 1. I will try with one more example. E to the power of 1 is approximately 2.82 and so on. So I will type the power, which is 1. Then I have to click on shift and on e to the power of x. And it gives me the value of the natural number. So this means that I should start typing the exponent first for this calculator. 0.03 times 5 equals. Now the base of the exponent is e, so is e. So click on shift, e to the power of x, and this is the value of the exponent e to this power. I need to multiply by 5,000 equals, and we have to round the result to the nearest 100 because this is money. The result is $5,809.17.